On Friday, oh, that just dated the recording. How about this? Last time we met, we talked about what a system of equations was. Can you remind me what a system of equations is? Because I've suddenly forgotten. What's a system of equations? The four of you who are here, I guess I should say.
A set of two or more equations with two or more unknowns.
A set of two or more equations with two or more unknowns. It's a set of equations, like more than one equation, right? That has the same solution, maybe or maybe not, right? And you'll see what I mean here in just a second. But one of the ways you can solve a system of equations is by graphing it. Okay? When it's a 2 by 2 system, wait, what does 2 by 2 mean again?
Two variables and two numbers.
Two variables and two equations, right? Okay, so if we have two variables and two equations, we should be able to graph them and find the solution that way, right? So, let's do what it asks. Consider the system. For each equation, make a table of ordered pairs and then graph each line, okay? So I'm going to do this first line in orange. I don't know if you can tell this is orange or not on the screen. I know you can on my screen, but up on the big screen, I don't know. Okay? So we're not going to take the time to put this into a calculator. We're just going to use our brains.
Uh-oh.
Don't say uh-oh. It's okay. You can do it. If x is 0, what is y? 3. If x is 1, what is y? 1. If x is 2, what is y? -1. If x is 3, what is y? -3. And if x is 4, what is y? -8 plus 3 is -5, right? So I'm going to plot those points over here on my graph, still with orange, so we can tell the difference. 0, 3, 1, 1, 2, -1, 3, -3, and 4, -5. So there's my line. Okay? Let's do the second one then. I'm going to do this one in blue. Again, I don't know if you can tell on the big screen, but I know you can tell on my screen. Okay? If x is 0, what is y? -2. If x is 1, what is y? 1/2 minus 2 is a -1.5. If x is 2, what is y? 1 minus 2, -1. If x is 3, what is y? 1.5 minus 2, -1/2. And if x is 4, what is y? 2 minus 2, 0. Good. Now plot those points on our graph. 0, -2, 1, -1.5, 2, -1, 3, -1/2, and 4, 0. Which ordered pair appears in both tables? It's right there, right? 2, whoa. Okay, 2, -1. What do we call this point in terms of the system?
The solution?
The solution. What do we call this point in terms of the graph? The point of intersection, absolutely. Okay, does that make sense? In terms of the solution, in terms of the system, it is the solution to the system. It's where they cross, right? It's the solution. But in terms of the graph, it's the point of intersection because it's where they cross. Okay? So, an important box. When the equations in a system can be graphed, good, then the solution to the system can be described using the coordinates of the point of intersection. Does that make sense to you? Okay, then answer this question. Why? Why is that true?
Because you can plug the points into the equation. Oh, just kidding.
What do you think? Is the only point that they share? Oh my goodness, that should be a capital I. Sorry about that. It's the only point they share. So let's do some examples without having to do tables. Nobody wants to do tables every time. I don't. Maybe it's just me. I don't know. Okay, so I'm going to graph the first line in blue. How do I graph that line without a table? Yeah, I think of where's the y-intercept? Where's the y-intercept? 0, 2. And then I consider my slope. 3 halves. I rise 3. From that point, rise 3, run 2. Rise 3, run 2. Or I can fall 3 and run backwards 2. Right? So that's one line. I'm going to draw this other line in orange. How do I draw that line? How do I graph it? Down 1. That's my y-intercept, right? And then what's my slope? 3 or run. So I rise 3, run 1. Rise 3, run 1. And then I could fall 3 and run backwards 1. So now I'm done. Why not? I graphed both of the lines like it said. Most common mistake people make when they do this is that they stop right here. Am I finished? No, what have I not said? The solution. If you do this and just go to the next one, you've shown me that you have a very strong grasp on an Algebra 1 skill of graphing lines. That's great. I'll clap for you, but that's not what we're doing anymore. We already did that, right? Okay? Now I have to say, oh my gosh, this is a system, and I know where to find the solution. It is where they cross, right? The point of intersection. So what is the solution of this system? 2, 5. And how did you figure that out? Because that's where they cross, right? I know that seems like a silly question, but sometimes I have to ask them. All right? Now are we finished? Yeah, that's good. Okay, now we go on to number 2. I'm going to graph the first line in blue. So I'm going to go up 7, because that's my y-intercept. And then my slope is negative 2/3, so I'm going to fall 2 and run 3. Fall 2, run 3. Fall 2, run 3. Or rise 2, run backwards 3. How many points am I drawing here? How many points do you have to make a line? 2, right? How many did I draw? All of them that I could. Okay, I drew all of them that I could, because then it's very clear where my line goes. Okay, I would like you to do that. I am modeling for you. Now, I know my hair looks great today. That's not what I mean. I'm modeling the behavior I want from you in your graph. Okay? So I'm going to graph the second line in orange. So I'm going to, fall 3, or go down 3 to on the y-axis. And then my slope is 1 over 1. Sometimes it does help if you make the sound, but you don't have to. So what is my solution? 6, 3. Any questions about that? You got that okay? Okay, so look at the back, which page 2, okay? These 4 you're going to have for homework. Okay? Look at page 3, ignore it, go to page 4. We have a table that we need to fill in right here on page 4. It's a pretty important table. What type of lines are these? They are parallel lines. I got to teach you some new vocabulary. Are you ready? Whoa, whoa. Settle down. Settle down. You're a little too excited about that. This type of system is called inconsistent. We're going to come back and talk about this when we get this whole table filled in. I just want you to get the vocabulary down for now. Okay? What type of solutions would this system have? Or no solutions. Okay? Some other vocabulary you need to know about this system. Sometimes the empty set is used to describe the system, and the symbol for empty set looks like this. Okay? It means there's nothing there. Nothing. No solution. Okay? All right, look at the next column. These lines right here. What kind of lines are these? The lines intersect. Good. What type of system is this? Any guesses? Consistent. Did you know that, or was it a guess? You knew it? It was a guess? Both? Okay, good. Okay. What kind of solutions are we going to have here? One solution represented by the point of intersection. Good. Excellent. If the two equations in the system graph into lines which intersect at a single point, then they are called independent equations. Again, we'll talk about it in a minute. I'm just trying to get you the vocabulary first. Okay? Last column. Do you see both lines there? Okay? It's meant to be that way. Okay? These lines coincide. What type of system do you think this might be? This is a consistent system. What type of solutions do we have? Huh? That's exactly what it is. An infinite number of solutions, or every I love when I see some of you thinking it, but you don't want to say it out loud, because then you're sitting there like this, because you're about to say point, so your mouth is ready for a P, but you don't say it out loud. You look silly. I'm just telling you because I'm trying to be honest. Okay? You make me laugh, that's all. Okay? Inside of my head, though. All right, I didn't laugh out loud. It's okay. If the two equations in the system have the same graph, then they are called? Any guesses? Dependent. Yeah, absolutely. Now let's talk about the vocabulary. Okay? Parallel, intersect, and coincide. Are we okay with those? These are parallel, they don't touch. These intersect. These coincide. They live on top of each other. Okay? What type of systems? Well, we have two types. We have inconsistent and consistent. Okay? So what do you think is going to help you know if it's inconsistent or consistent? If they touch, right? This one is inconsistent because they don't touch. Both of these touch. This only at one place, this at every place. Fair enough? Okay? What about types of solutions? Is this pretty easy? Either no solution, one solution, or an infinite number. Is there any other possibilities? Can you draw me a picture of two lines that cross in more than one place? You can? What does it look like? Okay, besides that. I'm saying like two solutions. Can we have like two solutions?
You could if you did like that. That goes this way. Then...
Okay, so what if we did a line and a parabola?
Yeah, that works.
That's great, but what did I ask for? Two lines, right? Okay, so if it's a line and a parabola, yeah, I'm going to have two solutions, right? Somebody said a cubic, which means I could do that, which means I could have three solutions. But again, we're only talking about two lines, right? So can I draw two lines that either are not one of these three but something else? I can't, can I? Okay, so these are my only three possibilities when I have lines. Okay? And the last one is other vocabulary. How are you going to tell the difference between independent and dependent? They both touch, but yeah, different equations. These two are going to be what? The same, aren't they? And these two are going to be completely different. All right? So you have 6 questions on the bottom. These are 6 of your homework questions. I would like to do number 11 with you. Okay? On the middle table is some graph paper. If you guys, everybody will get a piece of graph paper. When I check this on your homework tomorrow morning, this is pretty much going to be exactly the way it looks now, because all your work is going to be on your graph paper. Somebody grab me a piece, please. Thank you. I'm going to show you how I want this. Okay. Notice that I gave you a special piece of graph paper that has 3 graphs on this side and 3 graphs on this side, and then there's a whole bunch of white space beside the graphs. Does everybody see that? Whole bunch of white space? I'm going to zoom out just a little bit so you can see this. So on number 11, we'll call that one number 11. Let's go ahead and graph this. Okay, maybe I don't want to zoom out a little bit. So the first line crosses at 4 on the y-axis. Rise 2, run 1. Or fall 2, run backwards 1. Second line, I start down 1 on the y-axis, and then I rise 1, run 3. Or fall 1, whoops, 1, 2, run backwards 3. Okay, so the first thing it asked me to do is graph it. Okay, solve it graphically. I did that, right? I graphed it. Now it wants 4 things. First thing it wants is the type of lines. Okay? Who said that, by the way? Good. These are intersecting lines. Okay? It looks very similar to this one right here, and those type of lines were intersecting, weren't they? Okay? The next thing it wants is the type of system. And you say it's consistent? And it's consistent because they touch? Okay. The next thing it wants is the type of solutions. One. Oh, sorry. One. And the last thing it wants is if the solution exists, stated as an ordered pair. So the last thing is the solution. Well, what is the solution? -3, -2. Okay? It's okay. So on this graph paper, you're going to have the graph, and then you're going to have all 4 things listed over here. What happens if there's no solution? What are you going to write right here? No solution, right? I want you to write type of line, type of system, type of solutions, a solution for every single one of these on this paper. Because then it's all together and you know exactly what you wrote down. Some people these crazy kids last period wanted to just write these things over here. What does that mean for you in 2 days from now? Or 3 days from now? Nothing. But if you put these labels right here, you're going to know where that came from. Okay? Any questions? Do you understand my expectations? Okay, then what is your homework? 1, 2, 3, 4, 3, 4, 5, and 6, and then 11 through 16 on graph paper. Got it? Okay, so what's the most popular question right now? But what about 7 through 10? Extra if you want to do it. Okay? It's very similar to the examples that we did at the beginning. Right here, if you need to go back and look at that. Okay? But I more want to focus on these kind of things today for us. Okay? Any questions? Peace.